I'm going to welcome Gene from the Madison group, and he's going to introduce our special guest today. So take it away, Gene.
Thanks, Nikki, and good afternoon to all the students and teachers and counseling staff present today. So happy to have you join us. I'm Gene Dallenhoff with the Madison Region Economic Partnership, and we do economic development in the 8 counties of South Central Wisconsin. And a part of that economic development is really working with students to help them find really where their interests lie in terms of careers after high school. So we're happy that you joined us today. I have the pleasure of working with a number of companies across our region. And one of those great companies that supports our organization and does a lot for the community is Madison Gas and Electric. So I'm going to turn it over to Laura Caker from MG&E and take it, Laura.
All right, wonderful. Well, thank you all so much for the opportunity to join you here today. As Jean indicated, my name is Laura Caker. I am here along with Christina Shaughnessy, and we are a part of the talent acquisition team at Madison Gas and Electric Company. We have 2 engineers who will be joining us here today, and I'll announce them in a little bit later in our slideshow, but Harry Sutherland and Todd Montevideo. I'll give a little bit more of a thorough introduction in just a moment. Initially, I'm going to turn things over, though, to Christina to talk a little bit about who we are.
Yes, thanks a lot, Laura. Thank you, everybody, for joining this afternoon. We're excited about the opportunity, just like Laura said, the opportunity to be able to share a little bit about Madison Gas and Electric Company, or MG&E. We are a utility. Our home base is actually located kind of right in the heart of downtown Madison, just a couple of blocks off of the Capitol Square. And we have electric customers. It's about 155,000 folks that we provide service to within the Dane County area. So it's approximately half of Dane County. Our natural gas reach is just a little bit broader. We've got about 163,000 customers, so just under 165 there, and span into some of the surrounding counties as well. So we're actually a relatively small utility, especially when you look at some of the other utilities kind of surrounding us, like a We Energies, Alliant, much larger than us. We've got about 700 employees total, all who report into our Madison area. So been around for over 150 years. I think we've got a really good working relationship with the Madison area community. It's something that we certainly work very hard at and value as a whole, as the customers that we do provide service to. So with that, I'll turn it over back to Laura, and she'll talk a little bit about some of the career opportunities. So Laura, I'll let you take it away.
Thank you, Christina. So MG&E and the energy utility industry as a whole, we have a wide, as Christina was saying, a wide variety of career options that are available. And we do employ just over 700 people within our organization specifically. Some of the positions that our organization has, though they're critical to the smooth operation of our business, aren't what we would call, some of the industry specific careers. We have a variety of roles within functions like IT or human resources, which is where Christina and I both reside within the talent acquisition function. We have accounting and legal, many business related roles, customer service related roles. There's always going to be some nuance to the utility industry within those functions, but many of these positions also exist in other types of companies, great careers. But where we wanted to focus a little bit more here today is on some of the more industry specific or specialized careers. Those types of careers do typically require highly specialized or technical in nature training. We have roles like safety or field operations. So when people typically think about utilities, you'll think about line technicians or gas technicians, folks that come to your house and work with the meter and connectivity piece of our business. There's power plant operations. And these are all really, really fantastic opportunities that not all people know about or know how to really get into. On the very last slide of our presentation, I will share a Get Into Energy Jobs site where I encourage you to further explore some of those types of roles and some of the specialized education that goes along with those. But some of our more specialized careers are some of our engineering related roles. So we are fortunate today to have two engineers joining us, Harry Sutherland and Todd Montevideo, who are both engineers within our energy production division specifically. Both have different roles, but have agreed to join us to really focus and kind of spotlight those particular jobs, and to also really to begin to connect the dots of where does energy even come from. So with that, Harry, I will turn it over to you.
Thanks, Laura. I'm glad to hear that you guys are interested in STEM, and I wanted to kind of give you a bigger picture of the energy industry as it is. And so being interested in the STEM fields is going to set you up for being involved in supporting what you can see from the map is a large industry. So what you see in front of you is a map of utility scale, which just means large scale generating units. So when you turn your lights on at home, that power needs to get made somewhere. And you can see from the map, there are a lot of places that are making power and pushing it onto the grid. So the dots that you see are all locations where there are generating units. And the color of the dots will tell you what type of generating unit it is. And then the relative size of the dot will tell you kind of how big it is. Bigger dot, bigger generating units. You can see that in the middle of the country, there's a lot of wind production in green. That wind footprint is growing. You can also see the yellow dots for solar. Those are only going to grow in the next decade and even longer. You can tell that in the Northwest particularly, you can see that there's a lot of hydroelectric power available because of the topography in that region. There are a lot of natural gas-fired power plants. You can see the orange dots are nuclear power plants. There's still a fair amount of coal-fired energy production on the grid. So at MG&E, I work for the energy production group, and more specifically, I do work inside of our power plants, where I work on both capital and O&M projects. So if we want to upgrade some equipment, if we need to add some equipment or buy things to make our systems more resilient and reliable, or if we need to troubleshoot problems that we do have with existing equipment, I get involved in that kind of thing. But to support the energy industry more broadly, your interest in STEM subjects will be a good thing for you, because we're going to need engineers to support the industry to decide all kinds of things. How thick should that concrete slab be, and how much reinforcement do we need in it? How large of a pipe do we need to install for this? What material should that pipe be made out of? So material science is important too. This is to give you a sense of the scale of the industry. So MG&E is a smaller utility, but we're part of a larger whole. MG&E, and I guess Wisconsin itself, participates in what's called the MECO market, and that stands for the Mid-Continent Independent System Operator market. And you can visit MISO's website, and they can tell you that at any given point in time, they have what's called real-time displays, where they'll show you the fuel mix of all the power that's going on in the particular MISO footprint. So I took these screenshots from MISO's website yesterday, and you can see the proportions of where the energy is coming from. Some from coal, natural gas. You can see there's a bunch from nuclear and wind. The solar slice of the pie is smaller, but it's only going to grow because of guys like the next speaker. So MISO also looks to do forecasts to say, well, how much wind power should we expect tomorrow or the next day? And we know that if we're getting our power from wind, which is good, we can back off the throttle on, say, the coal production or the natural gas production. And so you can see the graph on the right shows the blue line, which is how much wind power is expected to be produced. And you can see that the green line is what we really are getting at any given point. You can tell that changes throughout the day. A lot of the fossil-fired power plants are following this load to make sure that everything's balanced. I look forward to answering any of your questions in the Q&A session. We can talk about any one of these things for quite a while. I guess with that, I'll hand it over to Todd. And actually, we have a video for you about a solar field that we've recently installed.
Well, we have over 17,000 solar panels here on 21 acres of land on the airport property. And the plant is rated at 5 megawatts AC, so it can produce 5 megawatts AC in the middle of the day during the peak times. This system is directly connected to the MG&E distribution grid. This will serve our shared solar customers, the city of Middleton, and the Middleton Cross Plains Area School District. This site has a single access tracking system. What that means is that the panels will continue to move throughout the day to track to the sun. The trackers have motors underneath them that actually move the panels. They have their own power through solar, and they also have sensors that know where the sunlight is so they can track to the sun. That means that this plant will be more efficient, and it also reduces the possibility of ever providing glare to any of the pilots. The collection system here, that's a series of cables, the red and white cables that are here, go over to the inverter. The inverter consists of electronics that take the DC and quickly switch it to turn it into AC. The electronics ensure that we maintain good power quality. From the inverter, it goes into a typical transformer. The transformer steps the voltage up to 13.8 kV, which is the voltage on our distribution system. This site communicates with our MG&E EMS system. The EMS system is our energy management system. MG&E is able to see exactly what this is producing at any point in time. And sometime in the near future, our customers will be able to look online and see the amount of energy that this plant is producing. The siting of a solar project on airport property is a really good pairing because you can see the profile of the solar facility is pretty low. You can't have tall structures near an airport. So it works really good from that perspective. You'll note that the panels have an anti-glare coating on them. That helps to both improve the efficiency of the panel by collecting more light and directing that towards the photovoltaic cells, but it also reduces the glare that the pilots would see. The plantings that we put in here will preserve the land and, in fact, in some ways improve the soil conditions. So if at some point in time we decided to remove the solar facility, say for different technology, the land would actually be in better condition than it was before we put the solar facility on it. I'm really excited about this project. It's the largest project that we've built so far. It's right in the Madison area. It's good to have the power right near the customers that you're serving it with. There's less losses, it's more efficient that way. MG&E customers have been asking for this type of energy. The MG&E employees are supportive of the project, and our shareholders. It's a great project.
To introduce myself, I'll give you a little bit of my background real quick. My name is Todd Montevideo, and I am the Renewable Engineering Manager here at Madison Gas and Electric. I've been in the utility industry for a little over 30 years now, in 3 different companies and a lot of different positions. So all of them have pretty much been related to engineering, although the amount of engineering varies quite a bit depending on what position you're in. So I've had quite a bit, like I said, experience in the utility industry. And I'll tell you, I think when I was in my junior high school age, I really didn't think that I would be working for a utility. I'm so happy that I did now. There's a lot of neat opportunities here, and I'll just be able to touch on them for you. So I hope you have questions for me after we're done. Like I said, I'm the Renewable Engineering Manager. So I lead a team of engineers that are responsible for our renewable fleet, which includes solar and wind right now. We put in quite a few wind plants. We have 4 or 5 solar wind plants that we own. There are 3 of them that we are strictly the operator of. So it's just strictly MG&E. The other plants we share with other companies. And our group is responsible for the construction of them and then the operational later on. So the construction of them, we typically will hire an engineering firm to engineer a project for us. And then we have input into the project. We share the ideas that we have with them, with the developers. And then we're there for the construction of them. So we get to go out in the field. So we're out in the field quite a bit and watching what's going on and answering questions. It's interesting, the topic that came up earlier about problem solving, that really is what engineers do. We solve problems. When we're out there, if there aren't any problems, we wouldn't have been needed. So the problems that are out there, it's our job to solve them. And they can be you can be a little scared. I'm sure you've had problems before in school, and maybe you're a little bit nervous when you first see it. You wonder if you can solve it. And then after you solve it, you feel really good about it. And that's what's really exciting about being an engineer, or other jobs that are problem solving jobs. So like I said, we construct these projects, we operate them. I noticed somebody said day by day, what do you do? It really varies on the job. So some people are doing more technical things on a day by day basis, analyzing, why is something not working properly? How can I put in a new system that might work better? Things like that. Other times we're managing projects. That's problem solving too. You go to put something in and you find out later on that, oh geez, there's a pipeline in the ground. So how do we fix that? Maybe you need to relocate what we're putting in, or find another solution. So yeah, it's all about finding solutions to problems when you're an engineer. And I just wanted to mention, okay, so the video you just saw, that was Maury Solar Field. That project went in July. And we have another project, Dane County Solar, which is going to be going into service this month. As a matter of fact, they're testing it right now as we speak. And if you ever go by the Dane County Airport here in Madison, you'll see the solar panels there. And that's our largest facility to date. And at the same time, we're starting another project in southern part of south of Madison in Fitchburg, city of Fitchburg, which will be even twice the size of the Dane County. So every time we built a project so far, it's been twice the size of the previous one. I know I don't have a lot of time, but I wanted to mention a few other things, and I think Harry can probably add to this as well. But our industry is really changing a lot. When I went into the industry, it was a lot of older technology. It wasn't a field that had the latest and greatest of things coming out. It's totally different now. It's we do have the latest and greatest technologies. And we're really in need of people that are interested in doing engineering, whether it be mechanical engineering, electrical engineering. There's an area called controls engineering. And I would suggest that if you like computers, if you like the Internet of Things, things like that, take a look at control engineering. Control engineering ties really closely to computer science. And in our group, we have people that do control engineering part of the time. In the future, I think there's going to be a really big demand for control engineers, SCADA engineers, things like that. And it ties right into the Internet of Things. So if you're interested in the Internet of Things, take a look at that. Look at a role as a control engineer or SCADA engineer, computer engineer in the utilities. There's going to be a lot of neat opportunities for you. I think that's pretty much what I had to cover. And once again, like Harry said, I hope you have a lot of really good questions for us, because we look forward to answering those questions for you.
Todd, I just saw a question in the chat that asked, what classes in high school would you recommend that students take if they're interested in going into engineering? And maybe could you also share what specific engineering path you took in your college coursework?
Oh, sure. Well, I think, first of all, you have to start with the basics. When you hear STEM, that is true. I mean, you need the math, you need science. I think something that people that are going into engineering often overlook is the other fields that maybe were not our favorite fields when we were in school, like writing and speaking. Those are things that you don't anticipate doing as an engineer, but they're there, and it's not something to fear. It's just like problem solving. As you start to do it a little bit, you get better at it. And as you get better at it, it can become more fun, and you get some reward out of it. So once again, I think the main things are focused on the core, the science, the math, things like that. If you're not sure if engineering is the right field for you, if they offer an engineering type class in school, I think that would be a great thing for you to take. Otherwise, they really tightly tie into some other things that you can take in high school, like shop classes and things like that, to learn how to read prints and measuring devices and things like that. I mean, that's the start of engineering. So I think those kinds of classes would be really good. I don't know if Harry, if you have thoughts on that one too.
Yeah, I can speak to that. So in high school, I took any AP classes that are offered for you in science and in math. I took some of those, and it paid some dividends later on when I went on to college. So I think I skipped this part of my background. I'm a mechanical engineer by training. I went to Iowa State University, and then after there, I went on to work for an engineering consulting firm. So let's say you wanted to build a new power plant. I work for people who would design new power plants, and whole teams of engineers are needed for that. So there are civil engineers, there are structural engineers, there are mechanical engineers, electrical engineers, and all working as a team on the full design of those plants. Todd is right in that you can't only focus on science and math. You will need to be able to communicate and convey your ideas to people and explain things in a way where you'll get your point across.
You mentioned the path. I didn't mention, and you reminded me there, Harry, of the path that I took. So I'll let you know. I was sort of fortunate in that when I was pretty young, I knew already that I liked engineering. When I was in actually grade school is when I started playing around with electronics, and that continued through high school. In high school, I'm older, so when computers first came out, that was something I was really interested in. So I played around with computers quite a bit, and that, along with electronics, really helped me a lot when I went to college. College was probably a little bit easier for me just because my interests aligned with what I was going to school for. So what I went to school for was electrical engineering. I did have two specialties. One was digital signal processing, which if you dig into it a little bit, I mean, that's really what everything's about nowadays is digital signal processing. Everything gets digitized and put into computers and processed. So that was my area of expertise. And then the second area was controls, control engineering. So those two were the areas that I focused on. I'm actually in the power field. That's a little bit unusual. Most of the people that are in the power field focused on power. And there are some very good schools in Wisconsin itself for engineering. And there's some good schools in northern Michigan for engineering as well. So any of those schools would be great schools, and they all offer some really pretty good power programs. So if you know that you want to develop power systems, there's a lot of good schools here in Wisconsin. I'm not going to name them because I'll miss some, but there's a lot of really good schools in Wisconsin.
So you guys are answering a lot of the questions that have come up already. So kudos for you. But here's one. How much do you work in an office versus working out in the field?
It's varied a lot on my career. So I spend most of my time in an office now. I'm a manager, and that's just what you tend to do. I'm more working with people. So where I was previously working almost primarily out in the field and working on equipment, now I've moved more towards working with people. It's really the same type of thing. You're solving problems. You're solving people problems now. Before I was solving equipment problems. And they're both rewarding in different ways. But I think what happens is as you develop your skills and get better at working with people, it opens up more opportunities. And for some people, it's more enjoyable. But did I answer the question? I think so.
Yeah, I think so. A two-part question coming up here. What is your favorite part of the job? And we'll say, what is your most challenging part of the job?
I'll let Harry go first.
Okay. So a favorite part of it is gratifying to see a problem get solved, to know that, hey, this system or this piece of equipment was acting up. It was giving our operators trouble, and finding a way to get that back under control or solve a problem and make life easier, make things more reliable, more resilient. That always feels good to walk away from that and know that, okay, that's better now, and not a problem. The most challenging part is usually the soft skills of handling interface with the people side of things, making sure everybody gets along. Sometimes people disagree, trying to go through things and make sure that you handle things judiciously, maybe with all the parties involved. That can be more challenging than solving a technical problem, because the answer to the technical problem is the answer to the technical problem.
My answer would be similar to Harry's. The problem solving is a lot of fun. It's really neat when you have a really challenging problem and people don't know what the solution is, and you come up with a solution. That's really rewarding. And it just gets bigger and bigger and bigger as you go. Like, for example, you saw the video of the Maury solar field. There are lots of problems that we ran across on that, and we solved those problems. And now when I go back and take a look at that project and look at what we accomplished, that's very exciting. It's really pretty neat to see where there was a field and now you have a green energy source there. That's a really neat thing. I think though, but what's even more rewarding than that is working with people and seeing the people grow. That's, for me, what's most rewarding. And I'm sure your teachers can relate to that. There's nothing that compares to seeing a person grow throughout their career. The most difficult, probably when I'm just sitting by myself, working by myself, and I'm not really solving a problem. I'm more like going through emails and things like that have to be done. They all have to be done, but you're not solving a problem. You're not working with a person. But there are things that need to be done. Those are the things that I like the least.
So both of you touched on the issue of working in teams, and then Todd, you just mentioned times you're working by yourself. What would you tell a student that is interested in engineering but really likes to work by themselves?
You really can go down both paths. There are engineering fields where you are working primarily by yourself. I'm going to tell you, I don't know of an engineering field where you're always by yourself. That just doesn't happen, because you're always working with other people. There's certainly other people going to be involved. So it's very rare that you just be working by yourself. But there are, like, if you go down the path of like doing more computer program development, if someone was out there, really interested in getting into like electronics, some of those careers are more where you're working by yourself. Ours, we work with people an awful lot, and that may scare some people, but it scared me. I'll tell you, when I first started, I was very, very scared of working with a lot of different people. I was a big introvert. The thought of me talking to a whole group of people would have scared me to death. But you grow over time, and it's not a big deal anymore.
I would say that it's inescapable having to interface with other people. So just for an example, so let's say you're a mechanical engineer and you design up a new, you have to replace a pump. Say you select the pump, you know how much flow needs to go through there, you know how much pressure it needs to make. Well, the pump doesn't just turn itself. You need to also be talking to an electrical engineer to make sure that the cable that brings power from the motor control center to the pump, make sure that cable sized correctly, and make sure that it has the right kind of insulation on it, and all of that. How are you going to control the system? So there is interface with other people for sure. And so the teamwork side of things, if you find yourself naturally disliking that more initially, that's an area that you should put more focus on and not avoid, in my opinion.
If you think about it, you'll never solve a problem on your own as well as you'll solve it with other people. If other people are giving you ideas, in the end, you're going to have a much better solution than you could ever have doing it by yourself, no matter how good you are.
That's true. And I guess I would say that other people might see problems that you don't. And might be able to offer ways to do whatever you're trying to accomplish in a way that's easier to construct, in a way that's maybe less expensive or more reliable. So people that have other perspectives other than your own, that's a valuable thing to get their perspective on stuff.
Well, that's a great question. You guys had a lot of input there. So a related question for teams. So the teams that you guys are working with, are they all individuals that have 4-year college degrees? Are some of them 2-year college degrees? Or some of them perhaps registered apprentices? Tell us a little bit about the teams you work with on engineering problems.
We work with all those people. I work with 4-year degreed people. I work with people that have 2 years degrees. Just yesterday, I was working with some line electricians. Line electricians typically have a 9 to 11 month program that they go through. We work with accountants. We work with HR. If you name a role, we probably work with them. Computers, we work with the IT department. We work with communication people that deal with cell phones and routers and phone systems. All that stuff gets involved. All that stuff goes into our projects. So we work with all those people, which is neat. It really is neat to meet all those people and work with all those different people.
I will too, just kind of add quick. I think if you're talking specifically, or if the question is specifically around engineers themselves, all of our engineers on staff at MGE are 4-year degree engineer. And kind of like, Harry touched on before, we have a whole bunch of electrical engineers. We have a couple of mechanical engineers, maybe even a civil engineer, but all of them do have the 4-year degrees.
And we do programs, and we do have people that have their professional engineer's license. I have my professional engineer's license.
So one more question we'll throw out here, and that has to do with really the potential for employment moving forward. So looks like there's a lot of education you need after high school. So what's the job outlook? So if I'm a student in 10th grade now, and I'm thinking about being an engineer and going into the utilities, is there going to be a job for me 6 or 8 years from now?
Do it. Absolutely do it. Yes, 100%. Engineers are always, I would say, highly sought after. Laura and I do a lot of recruiting with UW-Madison in particular, School of Engineering over there. And absolutely, the number of employers that participate in those events, is quite large. Absolutely. There's always going to be a demand for engineers, especially because the industry is changing so much. I would just say, food for thought to one of the things that Laura and I do notice year after year when we do go to the career fairs in particular is the lower numbers of electrical engineers. There's a lot of different disciplines. So electrical engineering, there's absolutely going to be jobs. I mean, there's jobs in any engineering discipline, but go for it. Highly encouraged.
I want to add on to that just a little bit to say that it's not only the utilities inside of the electric industry that are a place where you could go with an engineering degree or something that's fed by STEM. There are all kinds of things that are done to support that. So I work in power plants, but once the power is made, it goes on to a transmission and distribution grid. All that stuff needs to get designed. All that stuff needs to get built. All that stuff needs to get maintained. And even inside a plant, people need to produce the pipe, the fittings, the valves, and all these things need to be kept up with. A steam turbine, you need to take that thing apart and replace some things, make sure that everything's working right, and all of that. So there's a lot of places to support consulting engineers, metallurgy, all kinds of stuff.
I'll add a pitch just from my group. So I'm Renewable Engineering Group. Again, the person who had the position prior to me built the first MG&E wind plant in 1999. And I happened to work with them on that, working for a different company. And then about 10 years later, they built another wind farm. And 10 years later, they built another wind farm. And now this year, we're building 4 solar plants. So we went from one person then to there are 2 of us right now. Next month, there'll be 4 of us. And then I expect that we'll continue to grow. What we've done so far is just a drop in the bucket. We have a lot more to do. And we are definitely going to need more engineers, project managers to do that. So I'm hoping that I'll work with one of the people that are on the call today and they'll mention this presentation, discussion, and you and I will be working together in the future, building the next big wind or solar plant.
Great responses, guys. Appreciate it. We're running out of time. I'll kick it back to Laura for any last comments on behalf of MG&E, and then Nikki to wrap up.
Sorry, I just wanted to share one quick website slide here. A great resource you are interested in exploring is actually getintooenergy.com. So this isn't specific to Madison Gas and Electric. This is really specific to kind of a variety of both STEM careers and more specifically the energy utility industry. It's a great way to explore what your interests are. Some people are intrigued by energy but want to work with their hands. Some want to be more behind the scenes. Some like the systems, the people. There are such a variety of careers here that Christina and I really spend a lot of time getting out there and just exposing people to the industry and the breadth and depth of what we have to offer. So we really do hope that you'll be able to check out this resource and explore various career opportunities. One final thing that we love to be able to encourage students to do is take part in internship, whether it's these or career exposure opportunities, whether it's these types of job shadows, whether it's a ride along, whether it's a high school plant tour or any way to get exposure, or once you are in your college coursework, really making sure that that's what you're interested in doing internships and co-ops. These are such critical experiences that we can't encourage enough, and also encourage just general connection with anyone within our human resources team. We're happy to point you in the right direction. Sending questions through Zello. We're happy to answer any of the huddle questions that come in there. So hope that this is just the beginning of a discussion with you all and Madison Gas and Electric. But I want to thank you all for joining us here today.
Great. Thanks so much for joining us today. You've all been great listeners on this session, and we're happy to share these careers with you. So thanks again, and we'll see you soon.
Thank you.